Mars, the red planet, has always captivated our imagination. From ancient civilizations to modern science fiction, Mars has been a symbol of mystery and wonder. Its striking red appearance caused by iron oxide or rust on its surface makes it stand out in our night sky. But beyond its color, Mars holds many secrets waiting to be uncovered. It's a world of rusty red dust, towering volcanoes and vast canyons. Olympus Mons, the largest volcano in the solar system, and Valles Marineris, a canyon system that dwarfs the Grand Canyon, are just a few of its remarkable features. These geological wonders tell a story of a planet that was once geologically active and possibly even habitable. But did you know that a day on Mars is different from a day on Earth? While Earth takes 24 hours to complete one rotation, Mars takes a little longer. A Martian day, known as a sol, is approximately 24 hours and 39 minutes. This slight difference might seem trivial, but it has significant implications for our understanding of time and our future missions to Mars. It's true, Mars has its own unique day length, and understanding this difference is crucial for our future explorations of this alien world. For instance, the extra 39 minutes in a Martian day can affect everything from the scheduling of rover activities to the daily routines of astronauts living on Mars. Adapting to this new rhythm will be one of the many challenges we face as we prepare for human missions to the Red Planet. Our understanding of time is deeply rooted in the Earth's rotation. For millennia, humans have relied on the consistent 24-hour cycle to organize their lives. This cycle, governed by the time it takes our planet to spin once on its axis, has shaped everything from our work schedules to our biological clocks. We've divided our day into 24 hours, a cycle governed by the time it takes our planet to spin once on its axis. This division of time is so ingrained in our daily lives that it's hard to imagine living any other way. However, as we venture beyond Earth, we'll need to rethink our concept of time to adapt to the unique rotations of other planets. This rotation determines our day and night. The rising and setting of the sun, the changing of the seasons, and the rhythm of life itself are all dictated by Earth's rotation. It's a cycle that has been constant for billions of years, providing a stable environment for life to flourish. However, Mars dances to a slightly different beat. Its longer day means that the sun rises and sets at a different pace, creating a unique pattern of light and dark. This difference in the day-night cycle can affect everything from the behavior of potential Martian life forms to the design of solar-powered equipment. This difference, though seemingly small, has profound implications for future human missions to the Red Planet. As we plan for long-term habitation on Mars, we'll need to develop new strategies to cope with the extended days. From adjusting sleep schedules to designing new technologies, understanding and adapting to Mars' unique rotation will be key to our success on this fascinating world. On Earth, a day is approximately 24 hours long. This is the time it takes for our planet to complete one full rotation on its axis. Every day we experience the cycle of day and night as the Earth spins, bringing different parts of the world into and out of the sunlight. This rotation is a fundamental aspect of life on our planet, influencing everything from our sleep patterns to the way we measure time. This is the time it takes for our planet to complete one full rotation on its axis. The concept of a 24-hour day is so ingrained in our daily lives that we often take it for granted. From the moment we wake up in the morning to the time we go to bed at night, our activities are structured around this cycle. The 24-hour day is a constant rhythm that governs our work schedules, meal times, and even our social interactions. We call this a solar day. The solar day is not just a measure of time, it is a reflection of the Earth's relationship with the sun. As the Earth rotates, different regions experience sunrise and sunset, creating the familiar pattern of daylight and darkness. This cycle has been a constant presence throughout human history, shaping our cultures, traditions, and even our biological rhythms. But Mars takes a little bit longer to spin around. Unlike Earth, Mars has a slightly longer day, which means that its rotation period is different. This difference in rotation time has significant implications for any future human missions to the Red Planet. Understanding the Martian day, or sol, is crucial for planning activities, managing resources, and ensuring the well-being of astronauts. A day on Mars, known as a sol, is about 24 hours and 37 minutes long. This extra time might not seem like much, but it adds up over the course of weeks and months. For scientists and engineers working on Mars missions, this difference is a critical factor in designing schedules and operations. The longer Martian day affects everything from the timing of experiments to the planning of daily tasks. This difference might seem small, a mere 37 minutes. However, over time, these extra minutes accumulate, leading to a noticeable shift in the daily routine. For instance, if you were living on Mars, your day would gradually drift out of sync with the Earth day. This desynchronization could pose challenges for communication and coordination with mission control back on Earth. But those extra minutes add up over time and can have a significant impact on how we live and work on Mars. Adapting to the Martian sol requires careful planning and flexibility. Astronauts would need to adjust their schedules to accommodate the longer day, which could affect their sleep patterns, work shifts, and overall health. The unique challenges of living on Mars highlight the importance of understanding and preparing for the differences between Earth and Martian time. Imagine your alarm clock going off 37 minutes later each day. It would certainly take some getting used to. This gradual shift would require a new approach to time management and daily routines. Over time, the cumulative effect of the extra minutes would become more pronounced, necessitating innovative solutions to maintain productivity and well-being. As we look to the future of human exploration on Mars, understanding the intricacies of the Martian sol will be key to our success. Why is there a difference in day length between Earth and Mars? The answer lies in the physics of our solar system. Both planets spin on their axes, but they do so at different speeds. Mars, being smaller and less dense than Earth, rotates more slowly. Think of it like this. Imagine spinning a basketball and a tennis ball. The basketball, being larger and heavier, will spin more slowly than the tennis ball. The same principle applies to planets. The size and mass of a planet affect its rotation speed and therefore the length of its day. The difference in day length between Earth and Mars poses an interesting challenge for future human explorers. Our bodies are accustomed to the 24-hour day-night cycle of Earth. This natural rhythm, called the circadian rhythm, governs our sleep patterns, hormone production, and other essential bodily functions. Living on Mars, with its slightly longer day, will require us to adapt our internal clocks. This could mean adjusting our sleep schedules, using artificial light to mimic Earth's day-night cycle, and even developing new technologies to help us synchronize our bodies to Martian time. Imagine waking up on Mars, the red dust of a new world stretching out before you. The sky is a pale butterscotch color and the air is thin and cold. This is the reality that awaits future Martian explorers. The Martian environment is harsh and unforgiving. The atmosphere is thin, offering little protection from the sun's radiation. Temperatures fluctuate wildly, plunging below freezing at night, and the lack of liquid water on the surface makes it a challenging place to live. As the Martian day progresses, the sun slowly arcs across the sky, casting long shadows across the red plains. The Martian day, known as a sol, is slightly longer than an Earth day, lasting about 24 hours and 39 minutes. This subtle difference means that over time, the Martian clock drifts out of sync with Earth's, creating a unique rhythm for those who live and work on the red planet. The sun's journey across the Martian sky is a spectacle to behold, with the thin atmosphere allowing for a clear, unobstructed view of its path. The lack of a substantial atmosphere means that the sky doesn't scatter light the same way it does on Earth. On Mars, the sky appears a butterscotch color during the day, a stark contrast to the familiar blue of Earth's sky. This is due to the fine dust particles suspended in the Martian atmosphere, which scatter sunlight differently. The clarity of the Martian sky allows for stunning views of the horizon with minimal light diffusion, creating sharp contrasts and vivid colors. Sunsets on Mars are often muted, with the sky fading from a pale blue to a dusty rose. This phenomenon occurs because the thin atmosphere and dust particles scatter the sunlight in a way that creates these soft pastel hues. Unlike the fiery reds and oranges of Earth sunsets, Martian sunsets are more subdued, offering a serene and otherworldly beauty. As the sun dips below the horizon, the temperature begins to drop rapidly, signaling the onset of the cold Martian night. This unique day-night cycle has a profound impact on the Martian environment. The transition from day to night brings dramatic changes in temperature and atmospheric conditions. During the day, the surface is bathed in sunlight, warming the ground and creating a relatively mild environment. However, as night falls, the lack of a thick atmosphere means that the heat quickly escapes into space, leading to a rapid drop in temperature. This cycle of heating and cooling shapes the Martian landscape, influencing everything from dust storms to the formation of frost. During the day, the sun's rays heat the surface, causing temperatures to rise. The thin atmosphere allows for more direct sunlight to reach the ground, making the daytime temperatures on Mars surprisingly warm, especially near the equator. This warmth, however, is fleeting, as the lack of atmospheric insulation means that the heat does not linger for long. The surface can reach temperatures of up to 70 degrees Fahrenheit, 20 degrees Celsius in some areas, but this warmth is quickly lost as the sun sets. But at night, without the insulating blanket of a thick atmosphere, the heat quickly radiates away into space, resulting in frigid temperatures. The Martian night can be extremely cold, with temperatures plummeting to as low as -195 degrees Fahrenheit, -125 degrees Celsius in some regions. This extreme temperature variation between day and night poses significant challenges for any potential human explorers or settlers, requiring advanced technology and careful planning to ensure survival in such a harsh environment. The Martian day-night cycle is a testament to the planet's unique and unforgiving nature. The Martian environment presents a number of challenges for human exploration. The thin atmosphere makes it difficult to breathe, and the lack of a global magnetic field like Earth's exposes the surface to harmful radiation from the sun. Future missions to Mars will need to overcome these challenges. Habitats will need to be pressurized and shielded from radiation. Water will need to be sourced and recycled, and we will need to develop sustainable ways to produce food and generate energy. Despite the challenges, the dream of sending humans to Mars is very much alive. And when we do finally set foot on the red planet, we will be greeted by a new clock, a new rhythm to life. Adapting to this new rhythm will be crucial for the success of future missions. We will need to develop new technologies, adjust our sleep patterns, and perhaps even modify our biology to thrive in this alien environment. The exploration of Mars is a testament to the human spirit of adventure and our insatiable curiosity to explore the unknown. And as we venture further into our solar system, we will encounter new worlds, new challenges, and new rhythms to life. Mars, with its unique day length and its alien beauty, awaits. It is a world ripe for exploration, a blank canvas upon which we can write the next chapter of human history. Are we ready to embrace the red planet's rhythms and make Mars our second home? Only time will tell.